most appreciative of the fact that you are leading the charge of what it means to truly embrace innovative technologies and to provide a platform to share and exchange and cultivate even greater interest. So thank you for that. So I'd like to talk to you today about drones. And by raising your hands, how many of you have actually owned or operate a drone? Okay, we have some enthusiasts in the audience, great. Well, some of you may be questioning, why drones in transportation? What's the connection? I'm here to tell you there is an incredible one, and hopefully through sharing some of the applications that we have sought to date, you'll appreciate how drones could be leveraged in the transportation sector. A little bit about PrecisionHawk and our company. We're proudly here, headquartered in North Carolina, in Raleigh, North Carolina. We are a small business, and we really do provide end-to-end drone technology solutions and a full technology stack. And that comes for selling and providing drone hardware, and we're drone agnostic, to services that includes flight, data, as well as consulting services if you're interested in standing up drone services within your respective programs or companies, to software and the analytics associated with that, to training. There's Part 107 and also training on how to use some of the drone hardware and sensor packages, as well as one of the largest drone pilot networks with some recent acquisitions that we did in the past year. So we're excited about that to provide nationwide on-demand drone pilots to service your needs, as well as some of the future emerging capabilities of being able to fly BVLOS, where we have beyond visual line of sight offerings so that we can even extend into greater airspace and promote that value proposition. In this slide, I want to share a little bit of how drones are trending. Now, previously, drones may have seemed cost prohibitive. The cost of adopting drone technology may not have factored into the equation where you may take a chance on it. But in an environment where we're constantly needing to do more with less and budgets are shrinking, it's become a very timely equation to think about drones. And so with the flight times getting better and better, and they can last in the air and the duration, that is trending upwards. Sensor qualities are getting better. Not only are we talking about sticking a camera or a visual, to have a bird's eye view in the air, but with advanced sensors such as LiDAR and hyperspectral and thermal capabilities, the value proposition becomes even better when you can see things beyond the human eye. The size of these drones are getting smaller and smaller, and what that means is it's a greater ability to be mobile and packaged to go wherever it is that you need or intend to use them, as well as the computing costs. So, it's all about the drone data as much as we focus about the drones, and so the costs of actually, storing and ingesting the drone data and being able to analyze it makes it a valued proposition. This slide shows you a little bit about the life cycle, of where we're thinking about, drones and actually applying them today. So this represents a infrastructure life cycle, and so with that, in the early stages of planning, drones have been helpful, and I'll talk about a couple use cases where we have supported, where drones have supported master planning, environmental upfront baselining, using drone technology and flying over areas of interest, to design where drones can actually provide a digital record so that you can model and optimize the design of what you're intending to construct, to where you actually build in providing oversight of the construction crews that are physically building these assets, infrastructure assets, to maintain and operate where understanding what the condition of your assets are, your mobility infrastructure, your horizontal infrastructure, and when infrastructure has a greater probability of failure and where those failures are happening or where the greatest chances or risks are, is a great enabler provided by drones. And then lastly, when you're talking about some of these infrastructure assets reaching the end of their asset life, where do you reinvest and recapitalize or decommission these assets? And so not only is this pertinent to the transportation infrastructure, but we are also working in other markets and industries, such as construction, such as the utility space and renewable energies, the insurance industry, because drones are proving to be a very significant tool in the toolbox when it comes to assessing things across this infrastructure life cycle. This slide shows some of those applications that are most relevant when we're talking about transportation. And so I've had the unique pleasure of working very closely with North Carolina Department of Transportation on some of these use cases, and we're looking forward to do some more business in the future. But everything from coastline mapping to emergency response situations to just providing a good digital record of areas of interest, to floodplain mapping, to getting high digital elevation models and terrain modeling. These are all great examples of how drones could be used to collect data real time and capture the realities of the assets that that are in question or being assessed. And providing that system of record so that you can look for where the changes are ongoing with the continued use of drones. So here is where I'd like to pause for a second and talk about a recent support effort to North Carolina Department of Transportation. I wish it was for better circumstances, but it was, for the recent hurricane, devastation that impacted here locally. And, it was definitely our honor to support in a emergency management situation where our drone teams supported the Division of Aviation and their command center that was set up to fly drones immediately once it was safe to fly drones after the hurricane had come through, to provide immediate eyes on target and mobility infrastructure assessments. And so we're talking about the roads, major thoroughfares, some bridges and dams, but anything that would be of interest to the Department of Transportation and that would enable decision making of where to do closures, evacuations, when to reopen some of these major thoroughfares, because obviously those were going to help enable very critical and key decisions in a timely manner. And so our team supported a several-day operation in providing reality capture and real-time imagery, quick visuals, as you can see from the pictures here, of what was happening real time. And I think this is really key because although drones may have been used in previous hurricane efforts, never in such an organized fashion as the one that we saw here in North Carolina, where teams were mobilized in a very methodical way to support critical operations. And so we were very proud to be a part of that effort. And so what values did this support effort provide? Well, now suddenly you're operating with even more information, and information in areas that were otherwise inaccessible. We're talking about hundreds of road closures, washouts, and flashpoints, and water that continued to crest and peak. And so understanding what was happening hour by hour and how that environment was changing was so key to drive real-time decisions. And so, I think that value speaks for itself. But also, that is just for the immediate recovery efforts. What happens 30 days out, 60 days out, 6 months out, or even a few years out, as you continue to rebuild and recover, in the area, as you continue to feel the impacts of this storm. And so being able to use this digital record as a baseline for seeking funds that are needed to aid in those recovery and rebuild efforts is essential. And although this wasn't in support directly with the Department of Transportation here in North Carolina, We have also at PrecisionHawk been involved with other disasters, such as the wildfires in California, and alongside with that, utility infrastructure inspections. And so that's where our teams are actually still in the field, assessing poles and transmission lines and looking for where there are outages or vulnerabilities or where there might be vegetation encroachment, and assessing current vulnerabilities as well as what needs to be done, in the future, so that, that there aren't liabilities and we can protect public and get power back on in the quickest, efficient way as possible. And so this is a very powerful platform across multiple industries in an emergency response situation. And on the bottom graphic, you can see, I talked about LiDAR earlier, which is one of the advanced sensors. So what you see is a 3D, high-resolution 3D point cloud that provides engineering-grade data. And what that allows you to do is actually calculate volumetrics and understand, from a emergency response standpoint, debris field and removal of that debris that is obstructing transportation thoroughfares and roadways. So the higher end sensors, the advanced sensors, can provide a lot of capabilities that a human eye or a human analyst simply cannot get to without being directly in the field, which often is not possible in these situations. Here is sort of a moving video of a LiDAR point cloud, and it was actually in support of a project that we recently did for the Veteran Affairs Administration out in West LA, one of their largest VA campuses. It's a 380-acre campus. Just to kind of put it in perspective, we flew this campus with two-person pilot teams, and these are Part 107 pilots. And each team was equipped with a different drone, one with an RGB, so that's a visual drone as well as thermal, and the other with LiDAR. And it took about 2.5 days to cover, a 380-acre campus. And so when you put that in perspective, the traditional method would have been to send a several-person team to inspect every acre of that campus, and it would have taken several weeks. We've suddenly provided greater data in an accelerated manner, and now is put into a model which can be revisited so that data can actually be manipulated. You can interact with that data in a way that is distinctly different than traditional approaches. And just to share a little bit, at that West LA campus, it was in support of master planning efforts where there needed to be some environmental baselining. So our task at hand was to actually inventory and document every single tree on the campus, the maturity of the trees as well as the species, and we had identified over 132 different trees, 4,400 trees, and we're able to do that all with remote sensing technology. Also at the West LA campus, what you're seeing here is another project where we looked at all the horizontal infrastructure, the parking lots, the roads and thoroughfares, with the exception of one major thoroughfare where drones were just simply not allowed to shut down that particular thoroughfare. But what you see is the ability to take a very simple sensor equipped on a drone, a visual sensor flown relatively low, and its ability to detect longitudinal and alligator cracking and deficiencies and degradation within that, within the pavements. And we were able to do this by working with a partner that developed an algorithm, and this is where machine intelligence and AI comes into play. But now suddenly you've automated a function that again would have normally taken a person a long time to cover every particular mile, linear mile, and get the same assessment. And so and not only did we look at the severity of it, but the location of these deficiencies and what the recap cost would be with engineering data. This next slide, and I'm going to blow through this pretty quickly, just shows what the power of some of this drone technology can provide in advance of planning for emergency response services. And so this is a flood simulation model, but essentially it's looking at where does infrastructure start to fail, and when do you begin to care, and when is it going to impact your most critical infrastructure in a particular area, just based on running a flood simulation. So it could be very effective for pre-planning and disaster management in advance, as well as during. My last slide, I just want to talk very quickly about unmanned traffic management, because I think it's pretty key, and probably something that my colleagues here would also fit stomp, is that when we talk about UTM, it's really critical to think about what's the platform that's going to allow drones to be safely integrated when we're talking about manned aircraft and other things, and to deconflict this airspace as it becomes more complex and more congested in the upcoming years. And so, our thoughts is, let's really get ahead of this and really think about the right UTM platform that allows us to deconflict and detect and avoid, and make sure that what happened in Gatwick doesn't happen, with unintended hobbyists or more nefarious activities, which would be a lot more serious. But hopefully, through sharing this today, you come to understand why I'm passionate about drones and why I'm at PrecisionHawk, and see the value proposition when it comes to transportation. So thank you.
Thank you, Glady. Let's give our panel one more round of applause, please. Thank you for your patience, too. And before we get to Q&A, we have one polling question for the audience I think will be coming up. Let's see. Which is the strongest disruptor that you believe we'll see in the next decade? So there's your choices between drones, shared vehicle service, autonomous vehicles, electric vehicles. There's probably many others, even those we don't even know about, but those are your choices for now. So we'll see what comes up with the consensus. So about 60+% on autonomous vehicles, drones 21, shared vehicle services 13, and electric vehicles, I can't read that very well. You guys, I'm 56 years old. It's some number. Anyway. Did want to thank the panel for their great insights, and I'm going to ask a few questions, then we'll open it up to the audience. And the first is really important for me as a leader in state transportation. Part of an old slogan I grew up with through the military and the DOT is, if you fail to plan, you plan to fail. So how do you plan for what you don't know? So I'm going to ask this question. What do you believe transportation will look like in 2040? But I want your answer in your sector, because I know everyone here represents a different sector. So I'm not asking you to guess on some of these others, but what will transportation look like in 2040 in your sector? And anyone can start. We'll make sure we get to everyone.
Well, let me start, and the other guys can build on it, because we'll start with kind of the vehicle itself. So we believe firmly that electrification is the path of the future. We think that certainly by 2040, almost all vehicles sold will be electric and electrified, and so that is certainly one thing. I think by 2040, self-driving vehicles will be well established and integrated into the traffic infrastructure. There will still be human-driven conventional vehicles on the road as well, but we will definitely have self-driving vehicles involved. I think what we'll see as self-driving vehicles start to evolve is we'll see more specialized designs that'll be available. If you can remove the driver position from the interior of the vehicle, that starts to give you much more freedom in terms of how you can put the interior of the vehicle together and how you can make it more productive and more enjoyable for the people inside the vehicle and safer for everybody. So I think those are two major trends. I think we'll continue to see sharing evolve, and I'm very hopeful that we will see that evolve and work with public transit. I think that's one of the key things we all have to work on as we go forward. We're at the very beginning of all of this, and we have to learn, what are the right models, what are the right business models, what are the right models for the most efficient movement of people in an independent and liberating way. So we'll start there, and we'll let everybody else go.
Should we be orderly and just go down the line?
Oh, anyway, jump in.
Well, I'm a rule follower, so I'll just go next. So I think from a transit perspective, what you're going to see is transit's going to be connected with everything, right? As I mentioned before, this idea of seamless mobility, where transportation, I think, will be more like a public utility in the sense that it just fades into the background. You don't think about it. You don't wake up in the morning and say, should I hail an Uber or a Lyft today, or should I drive my car, or should I do this? You won't do any of that. You will wake up and you'll grab your smartphone, or this phone will already know where you're going that morning, and something else will determine the best way for you to get there, and you'll just follow along. I think from a public transit standpoint, so it's interesting, in 2017, public transit did more than 10 billion rides just in the US, which is far beyond anything else by orders of magnitude. And I think that what you're going to see are far fewer fixed routes per transit agency, much more flexibility, but much more public transit access, and public transit will be everywhere across the country because it can be more flexible, more dynamic, significantly lower cost with on-demand and things like that. So I'll leave it there.
From the infrastructure side, and we're already seeing this today, the traditional highway safety devices and things that you may not think could be smart are eventually going to be in some way connected to these new automated vehicles. And the way you get there is, localities like North Carolina or cities have to start collaborating with the automated vehicle developers, the transit agencies, to start piloting some of these concepts to show, what are the benefits going to be, and what are the best practices that will be used in the future. And really just kind of the concept of connectivity. Roads are going to be connected to these vehicles, and the amount of data that's going to be generated from all these different vehicles flowing through to traffic management operators, and the benefits there are huge. And I think that's really where we're going to start seeing some of these positive benefits for infrastructure owners and operators, is getting hold of this vast treasure trove of data to be able to make informed decisions about how to respond to maybe some incident management. How do we get automated vehicles to know that there's perhaps an ambulance or an emergency responder coming down the highway? So it's those types of situations where I think we can find really benefits by 2040.
I'll just add, I agree with a lot of that, but I think the data and the technology that are going to be available in this space are going to mean that we can take a much more system-wide approach to how we think about transportation planning, and we can start to actually plan for the individual and the transportation decisions that they need to make in a given day, so that they can essentially be surfaced the best options that work for them and for the system overall. And I think that's a big space where you'll start to see a lot of innovation, is really focusing in on why do people take transportation, and then designing to meet those needs maybe a little bit more efficiently.
From a drone standpoint, I think the options and opportunities are limitless, but the way our cities are going to look in the future are going to be drastically different than today, where drones are going to be much more integrated in our most urban centers, for urban air mobility and moving people, to packaged goods, to even providing new thoroughfares, and less congestion on our roads, to where roads might not be the main thoroughfare, for transit from one location to another. But I also think it's going to transform drastically the way that we even construct in the future, mobility infrastructure. If you look out your window today, I can guarantee the way that we construct our roads or our houses or commercial buildings is the same as when it was 50 years ago. And so I think that begs that we need to do more and we need to really drive further transformation. And I really think drones will come into play where, things like, drones are going to become the robots that actually help and enable, construct, and provide a safer manner to do so. Not removing humans in the loop, because I think humans will always need to be involved to safely integrate drones in all of these applications, but to invest their time for the things that are going to be most value add, for the experts, but allowing drones to do things that are rote or can be automated.
Good. So after you describe the future, now tell me, what is the biggest inhibitor to faster and earlier adoption to what you just described?
Well, I think policy is certainly very important, and it is very difficult for policymakers to attempt to grapple with this type of a future, and especially where we sit today. All of this is very much in its infancy, and so to try to project that forward is very difficult. And where we find ourselves engaging with policymakers, what we encourage them to do is not to try to, we're familiar with a paradigm where we've had 100 years to evolve our transportation policies and regulations to the world that we live in today. We need, and I think all of us need, the space to be innovative, to be flexible, the environment to be flexible, so that we can try out these new things and figure out which ones work and which ones don't work. So we encourage policymakers not to jump in and try to put the solutions that we live with today on top of all of these new technologies. Hit the pause button. Let's get these technologies on the road and start to see what works and what doesn't work before we start making policy that impacts which ways things might go or not go.
Yeah, I agree with that, and I'm gonna go a little rogue, and I'm gonna give you two, but I'll be quick about it.
Yes, yeah, two's fine.
So I took some pot shots at Nick and Uber earlier, but I actually think that one of the biggest problems has been, for public transit in particular, fear of failure, right? Don't rock the boat. When I came to TransLoc, I heard, we get $54 billion a year in funding. Doug, just, what are you doing? Just leave us alone, let us do our work, everything is good. And if we tried anything now, we're gonna get in trouble, I'm gonna lose my job, I'm a government official, et cetera, et cetera. Uber actually really pushed things forward to the point where transit agencies recognized the world's changing, Uber's helping to change this world. If we don't change with it, we're gonna get left behind, and we should be at the center of it. And so over the course of the last few years, they've been more willing to experiment, low-risk experimentation, but experimenting nonetheless with new technologies, and that's changing the game. So props to Uber for that. The extension of policy is procurement. I'm probably gonna make myself very, might become the enemy in this room, but my God, procurement is slowing everything down.
It's a nightmare.
It is a nightmare, and if we could change it, we will help these transit agencies and others that want to experiment and want to serve their communities better and faster and are being held back because of bad procurement policies.
It's pretty clear, the current state is that, localities like North Carolina and states are really leading the way in terms of policy and regulation of automated vehicles. And they're kind of just trying to let the market, determine what exactly are these vehicles going to look like? How are they going to operate safely on public roads? And I think that's important because you don't want to stifle innovation. You want to let this technology grow and mature, and you don't want to cap it too early with damaging regulation. But from the infrastructure side, I think it's going to be important that we look at uniformity and standardization. The GM gave a congressional testimony a number of years ago that talked about uniformity in traffic control devices and pavement markings. So those things are going to be very important to establish a glide path for government agencies and regulators to start figuring out what is it that we're going to need in the infrastructure that's harmonized and important for these vehicles to operate safely. So that could be a barrier as well if we don't get there.
I don't have a ton to add here. I think that the rate of change, the rapid rate of change right now is something that people are, they're struggling with across all these different sectors, and it creates a certain amount of uncertainty and anxiety in the general public. But I think that smart public policy that allows space for innovation to try to get to those fundamental goals that government and the private sector share, especially in transportation, which is helping people get around. I think that's going to be that close, good working relationship is going to be the most important thing to really focus on.
I agree with everything that's been said. The one I'd probably add is public perception, in that sometimes a simple event, and I talked about Gatwick earlier, and we chatted about that even before the panel, where something as simple as that, that created drastic consequences and impact both financially into a ton of passengers, last month in December in Gatwick, could change public perception, and there could be